Or 2 afternoons. Okay. Okay. Oh,
Okay, so you need to collect 2 morning session and
thank you.
get that 4, right? You can collect a customized walker from the booth. Or either 2 mornings and 1 afternoon session after tea.
Thank you.
Okay, I'll stop last.
Thank you.
everybody. Hope you all have a good lunch. Okay? So how's the lunch? Good? Usually good lunch means food coma, right? So usually I prefer not to teach after lunch. Right? So my content should be more interesting enough to fight food coma. Right? So let's see. Alright, so welcome to my talk, right? So my talk topic will be embodied intelligence. Okay, so I'll explain embodied intelligence in a while, and also bridging the physical interaction and cognitive adaptation, in a robotic system. Alright? Okay, so I think most of you already know what's NUS-ISS about, right? So so our mission is actually developing digital talent, okay, through education, applied research and consulting, and career services. So we already trained over 200,000 professionals and working with over 9,000 corporations. All right. So a brief introduction myself. My name is Xavier. I'm currently senior lecturer in NUS, and okay. So I teach in NTU. Okay. So I teach master and PhD student in the area of robotics and also industrial automations. Okay. So before that, I was a senior scientist at A-Star, leading multi-million dollars government initiatives. So some of my robotic solutions have been licensed to industries. Okay, so my research area is autonomous system, industrial toolpath optimization, and also 3D image processing. All right? Okay, so for today's agenda, right, so I'll first talk about the core paradigm of embodied intelligence. So what's embodied intelligence? Recently the word very hot, right? And then I will talk about the difference between bio-inspiration robots versus embodied intelligence. Okay, so the keyword is beyond surface mimicry. Okay, so then I will talk about the embodied intelligence at the edge. Okay, so what's the correlation between embodied intelligence with Industrial 5.0? Okay, so lastly, I'll bring back to Singapore context. What shall we do? All right. Okay, so before we go in full technical, let's do a quick quiz first. Okay, so based on our current understanding of embodied intelligence, right? So if embodied intelligence, or a person at the gym, what you think you will do? Okay, in your own opinion. So try to find the best answer. Okay. So later we'll do a quick show of hands. So first one, try to copy someone deadly form but end up inventing interpretive yoga. Right. So second one, drop dumbbell on your feet 3 times and then realizing the glove doesn't help. So number 3, perfect push-up technique through tiny adjustment, and number 5, spending the whole session lying on the mat. Okay, so let's do a quick show of hands. So who think the first one is the best answer? The best answer representing embodied intelligence. First one. Nobody? All right. So the first one actually is more like creativity, right? A lot of creativity, but not much motor learning. So embodied intelligence is focused on motor learnings, learning from the dynamics environments. So how about the second one? The drop dumbbell on his own feet 3 times before realizing the glove doesn't help. So who think the second one? Also nobody. So this one is more like trial and error, right? But more on error side, right? Drop 3 times, then only until 3 times you realize doesn't help with the glove doesn't help with the balance. So who think the third one? Okay, so I think most of you already know what embodied intelligence is, right? So this is the perfect answer for embodied intelligence. So the AI plus the physics body, right, interacting with the environment, okay, and then perfect through each reps. So adjustment at each reps to make it perfect. So this one is a perfect example of embodied intelligence. So how about the last one? Laying on the mat and dreaming about the texture of the floor. This one is more like embodied curiosity, right? Not much intelligence. Okay? Okay, so I think, okay, so my point here is, right, so the AI now is not only inside the computers, the monitor, the keyboards. Okay, so AI has already stepped into the real world. For example, the first one, this one is a video I take at San Francisco. So this one is a way more autonomous or driverless vehicle cruising through the Chinatown at San Francisco. Okay? Sorry, let me play the video. Okay? And the second one is ISO speed, right? This influencer, he shot over this delivery bot. But not this very common, right? Delivery bot. Okay? And last one is Tesla, the most advanced Optimus Gen 3 humanoid robots. Okay, so you can do all the house chores, right? Folding your clothes, washing your laundries, also can work in the factory, right? Factory do machine tendings or do assembly tasks, right? So my point here is, so AI is no longer just algorithms. Okay, so AI has already been engaging with the physical world, okay, in a way that more natural, seamless, also intuitive. So that's a new trend for AI. Okay, so now before we go into the paradigms of embodied intelligence, right? So let's talk about what's the capability, different capability of AI. Okay, so AI can be further categorized into 3 categories. So first one is artificial narrow intelligence, which means the AI is only designed for specific tasks. Okay, so artificial general intelligence means AI is match the human capability in all aspects. Okay, so matching. Okay, so it can generate a generalized knowledge. So last one is artificial super intelligence, right? So it's only theoretical because whether we can achieve artificial super intelligence, right, depends on whether we can achieve artificial general intelligence. Okay, so it's only a theoretical concept. Okay, so it means the AI surpass human in all aspects. Okay, so make a guess, where are we now? Artificial narrow, or general intelligence, or super intelligence? Where are we now? Which one? Yeah, I think my student already know, right? Artificial narrow intelligence. So we are still here. Okay, so optimistically speaking, we are 5 to 20 years away from artificial general intelligence. So depend on technology advances plus whether the society is ready to embrace the general intelligence. Okay, so we are still here. Okay, so most of the AI you see on the market, right? Whether Netflix recommendation system, or your email spam filter, or your chatbot, autonomous vehicle, facial recognition. So these are all examples of narrow intelligence, or we call it weak AI. Okay, so then how about ChatGPT? Whether ChatGPT is a general intelligence or is still narrow? ChatGPT. I think most of you are already using, right, ChatGPT, right? So ChatGPT, no, it's still not general intelligence, even though it can generate human-like text, right? But it doesn't have the true understanding of the knowledge. Okay, you also don't have the self-awareness. Okay, so ChatGPT is not an AGI. Okay, but how about embody? Is ChatGPT an embody intelligence? Yes or no? Based on our understanding, right? It's still no, because it doesn't have a physical body. So even though it has a prompt, right, you can actually interact using prompt engineer, but it still doesn't have the physical body, sensor, or direct interactions. Okay, so it's actually only possess the language tokens through the statistics patterns. Okay, so not through the sensorimotor experience. So this is a key for embodied intelligence, sensorimotor experience. All right. Okay, so now let's go. So let's talk about the core paradigm for embodied intelligence. So what's embodied intelligence? Okay, so there's a very famous French phenomenology philosopher. So his name is Maurice Merleau-Ponty. When I say Merlot, right, I think some of you already think about the fruity wine, right, with mild acidity paired with the Lincard stick. But no, this one is not the wine. This one is the Merleau-Ponty. So he's a French philosopher. So he once said, our body is the general medium for having the word. Okay, so what it means is, okay, so it means the body is a mediator. Okay, so we don't just use the body. So our body is the way we perceive, navigate, and make sense of the word. And also, the perception navigation is not purely mental. It's not just the brain thing and body will act. Okay, so they are both grounded in the body presence. Okay, and also we have embodied our experience from vision, touch, movements, and also posture. So they shape the what appear to us. Okay, so Merleau-Ponty actually his perspective, right, actually move away from the Cartesian dualism, which means we separate the mind with the body. So his perspective actually inspired a lot of thinkers like Varela and also roboticists like Brooke or Pfeiffer. Okay, so he laid the foundation for embodied intelligence back in 1945 when the World War II just ended. Okay. Okay, so this is a word cloud I crawl over the internet. So you can actually have a glimpse of what embodied intelligence is. So the larger the words, right, so the more correlation it has with embodied intelligence. You can see, right, embodied intelligence actually related to morphology, environment, perception, computational, control, compliance, dynamics, and also feedbacks, environment. Okay, so so you can actually, like, from this word cloud, right, you can know what embodied intelligence is. Okay. Okay, so the embodied intelligence is the idea that intelligence is not arise solely from the abstracts. Okay, so residing in the brain. So it's not only in the CPU, computer, or your brain. Okay, so but it emerge through the interaction between the body, environment, and the control system. So that's the embodied intelligence. Okay, so in biology, right, so the embodied intelligence actually highlight how the animals, right, rely on the body structures of muscle, hand, eye, right, to perceive, adapt, also act intelligently. For example, the sloths, right, we all know the sloth is very slow, but they are still very intelligent. They can use the curved claw and muscles to climb the trees, also to clinging on the trees without falling. So this is one example of embodied intelligence. Okay, so anybody play basketball? You all know Stephen Curry? So Stephen Curry is the all-time greatest three-point shooter in NBA history. Okay, so when he shoot a basketball, for example, if a defender was 2 meters away from the Stephen Curry, right, whether his brain thinks like there's a defender 2 meters away, so I might have to take 2 steps to the left and then shoot a 47 degree and also use a 70 Newton of force. No, right? He's just using his muscle memory because through years and decades of training, right, his muscle already have the memory of these shooting motions. So when you want to shoot, right, he just take a look at the defender and then just release the ball. There's not much reasoning inside. Okay. Okay. Also, when it comes to robotics and AI, right, so embodied intelligence actually refers to the machine whose physical design, sensor ability to move and act in the world are all integrated into the intelligence. Okay, so you all have saw this video, right? Okay, so this year in China, so they have this humanoid Olympics where they let all these kind of humanoid robots, right, to do track and field, right, to do boxing, to do marathons. So most of these kind of movements, right, is not trained before, never trained before. But why the robot can still balance is because the embodied intelligence. Okay. So another characteristic for embodied intelligence, right, is a closed loop. Okay. So intelligence is not just pure algorithms. Okay. So embodied intelligence actually is actually a closed loop between the body, sensor, learning mechanism, and also the environment. Okay. So the sensor actually captures the information from the environment, and then then the learning mechanism will start to learn and also to draw insight from the environment, and then your body will start to act, right. Then you'll further affect the sensor perceptions. So it's a closed loop. Okay. And also, instead of viewing the robot as a processor, right? So actually, embodied intelligence, right? We treat the robot as a living system. So it's similar as human and animals. It's just a living system. Okay. Okay. So the embodied intelligence is grounded by the 3 philosophy principles. Okay, so these are the foundation for embodied intelligence. Okay, so these are the words of embodied intelligence. Okay, so the first one is the situated intelligence, which means our understanding of it is shaped by the specific of body. For example, we have 2 eyes, right? We can have stereo visions, and then if we stand upright, right, we can have better perspective. So that is called the situated intelligence. Okay, so secondly, the sensorimotor couplings. Okay, right, the knowledge will arise through the doing and sensing, not just thinking in the brain alone. Okay, so it's all connected. So the last principle is the pre-reflected actions. So many of the actions, for example, catching a ball, or when we're walking, right, when we trip by objects, so it's all reflexes. Okay, so there's not much thinking or reasoning in the brain. So it's all pre-reflected actions. Okay, so guided by these 3 principles, right? So these 3 robotics pillar is how we implement embodied intelligence. Okay, so the first one is morphological computation, which means we design the body's shape compliance. Okay, so to reduce the control complexities. So this one is corresponding to the first situated intelligence. Okay, so the second pillar is perception action coupling, right? So it's corresponding to the second principles. So which means our policy must make sure we take input from the vision, touch, also perceptions. So taking control of all the sensors and actuator informations. Okay, so it's actually a joining force of perception actions. So lastly, learning under constraints. So this one, as summarized, is welcome to the real world, right? So the real world is always real time, dynamics, and partially observatory. So this partially observatory is always happen. Like for example, when you want to use a robot to pick and place from a densely packed bins. Okay, so all the products are densely packed to each other. When I want to use a robot to pick and place all the object, right? So most of objects based on vision there's a lot of occlusion, right? So that's why in real world, there's a lot of partially observatory. So we must make sure our learning policies to take into consideration of the safety bounds and also the sparse rewards. Okay, so let's go one by one in details. Okay, so the first principle, the first pillar is morphological computation. So this actually means the robotic shape compliance materials will offload the computational demands. Okay, so for example, so this is actually a passive dynamic worker. So this is a robotic skeleton developed by Cornell Robotic Labs. Okay, so you can see the robot can just walk the slope, okay, using only the gravity and also the leg mechanism. Okay, so there's no active motors or controllers. Okay, so this is one example of morphological computations. Okay, so this is actually inspired by the muscle. But the muscle can actually store or offload the energies. Okay, so the implications of morphological computation is first, you'll reduce a lot of control complexities, right? Just like I mentioned. Okay, so because a compliant or well-defined shape, body shape, right, will naturally stabilize the motion. You don't need much micro corrections at all times. Okay, so secondly, it's also very energy efficient. For example, this one, it don't cost much energy, right? It just uses gravity, so it's very sustainable. Okay, so thirdly, the engineer must learn how to trade off between the morphology and also the control. You cannot over-reliant on the morphology, because if you over-reliant, right, the body is only optimized for what it's designed for. So we are restrict for the body to for the robot to adapt to other tasks. Okay, so that's the first principle. Okay, so how about the second principle? So the second principle is perception, action, coupling. Okay, so this principle actually means the perception and action are tightly intertwined. Just I mentioned, right, they are connected to each other, and also the action will influence what the sensor detect next. Okay, so you can see, right, this is a robotic whisker. You all know that rodent or cats or even rats, right, they have this whisker. So the whisker, they can sweep the whisker to detect the object surrounding these kind of rodents. Okay, so this robotic whisker is actually inspired by this rodent whisker. Okay, so they can actually sense the textures and the shape of objects. Then you can use for navigations. Okay, so the implications of perception action coupling, right, is first is a closed loop intelligence, right. So system must integrate all these kind of perceptions, visions, touch continuously. So it's a closed loop. And also the movement must not only learn, not only to act based on the sensing, but also to sense through acting. So acting will also affect the sensing. So lastly, when we design the policy, right, we need to make sure our policy will encourage the act to improve the perception. For example, when the object is partially occluded, right? So our act should be move the robotic body to have a better perceptions. Okay, so lastly, when we design the reinforcement learning, right? Okay, so we must accommodate the information gathering actions, not just goal-oriented. Okay. Okay, so the last pillar is learning under constraints. So this one is actually the real world, right? When we're using our robot in the real world, right? So it's always planned under constraints. Okay. So the real world learning is bounded by time, by safety, by limited observability. Okay, so for example, when in school we have a constraint, right? When in our workplace we have constraints. When we take transportation, also have constraints. So the real world is full of limitations and constraints. Okay, so when we train our robots, right, we must also take into consideration of the constraints. Okay, so for example here, this one is an example of deep-mind local motion agents. Okay, so this you can see, right. So this is the virtual environment with all the physics laws. Okay, so even though some of the motion here are very exaggerated, right, very quasi, right, but actually through millions, hundreds of thousands of training, right, so the motion will slowly getting more and more natural. Okay, so the implications of learning under constraint, right, first is we must actually make sure it's a safety aware, make sure it's have the safety awareness. Okay, because our policy must respect the constraints, right? Because our robot will be interacting with the real world. So we must make sure we take into consideration our constraints. So don't fall over, don't damage the environment. Okay, so that's why we have the risk awareness, the reinforcement learning. Okay, so secondly, it's always partial observability. Okay, so system must infer the hidden states. Okay, using like recurrent models or memory or filtering. Okay. So thirdly, we must make sure how to call the shot, right? Because we cannot have endless trial and errors. So we must know when to stop, even though the solution is suboptimal. Okay, so lastly, it's always real times. Nowadays, you heard there's a physical AI as well, right? So what's the difference between physical AI and embodied AI? So the answer is actually here, real times. Okay, so for embodied intelligence, because it must require a physical body. Okay, so it must react in real times. But physical AI, right, it might be trained in the physical environment. It might don't need to react in real times. Okay, so for physical AI, it might also just be the robot models inside these physical virtual environments. Okay, it might not have a physical body, but for embodied intelligence, right, there must it's compulsory to have a physical body. Okay. Okay, so just now we talked about the core paradigm of embodied intelligence, right? So now let's talk about the bio-inspirations. Because just now I show you humanoid robots, right? Also showing some of the robotic arm, right? So they are very similar to bio-inspiration robots. So what's the difference between these two? Okay. Okay. So anyone heard of a cosmic calendar? Anyone? Right. 1, 2. Okay. So this cosmic calendar is actually it will compress the entire universe history to 1 calendar years. So the Big Bang actually is the midnight, right? If the Big Bang happened at the midnight, January the 1st, okay, then now it's actually the midnight 1 year later, okay? So the modern human only emerged at the 31st December, 9:25 p.m. Okay, so compared to other animals, right, the dinosaurs or amphibians, right, we have relatively very short history, right? Humans have very short history, okay? So, but we are the most intelligent beings on Earth, right? So that's why we develop AI, we develop nuclear power, right? Can disrupt the whole planet Earth, okay? So if we compress furthermore, right, compares to the entire universe of history to 1 day, the human only emerged 1.5 seconds before midnight. Okay, so we have very short histories. So that's why there's a lot of life forms before humans. For example, the multicellular organisms, or even vertebrates, or even mammals. We have a lot to learn from other life forms. Okay, so that's where the bio-inspired robot, the idea coming from. So we learn from other life forms. Okay, so bio-inspired robots. So they are robot system mimicking the organism behavior found in nature. So the goal is to enhance the functionality in the complex environment. Okay, but not all bio-inspired robots are have embodied intelligence. For example, the ant colony optimization is just an optimization algorithms. So they don't have a physical body. So it's not embodied intelligence. Also, not all embodied intelligence is bio-inspired. For example, the autonomous vehicle is not bio-inspired, right? So you will have the embodied intelligence in the bio-inspiration robot, right? So we must choose the body control and also let the morphology to solve the task. So lesser brain is needed. Then it can be called a bio-inspiration robots with embodied intelligence, right? Okay, so these are some examples of other type of bio-inspired robots. Okay, for example, the most common one, right, robot dogs, right? The multi-leg locomotion can through rough terrains. For example, the Boston Dynamics sport. Or we have, flying robot inspired by birds or bats, right? So they can flapping the wings and also gliding for efficiencies of flight. Okay, so others inspired by the facials, right? So they have a streamlined bodies and also the fin can, do propulsions. Okay, so others such as the soft robot inspired by octopus, right? So they have flexible, deformable structures which can pick up the object with various sizes and shapes. Or we can even study the behaviors, animal behavior, for example, the swarm behaviors of animals. Okay, and then even have micro or nano robots which can go inside of blood vessels. Okay, so if the table is not visual enough, right, I have a video for you. Okay, so I actually demonstrate 4 types of bio-inspired robots. Okay. Okay, so the first one is actually inspired by gecko, right? So gecko, they have these cohesions, also compliance the food, right? They can actually walk on the walls or even on the ceilings. So the first one is inspired by geckos. The second one is inspired by the sea snake. So they can actually swim under the sea and also do inspections of the key infrastructure under the sea. Okay. We also have nano robots, right? So nano robot can go into the blood vessel and remove the blood clot, or even delivery medicine at precisions, right, to different organs. Okay. So this one humanoid, right, doing parkour, even some motion back feet, front feet, right, I also cannot do, right? So they can also solve robotics. These are octopus tentacles, right? So they can, carry objects with various sizes and shapes, also even weight. Okay, so because these tentacles, they can actually accommodate because it's soft. Okay, so last one is the robot dogs, right? So they can use, they can open doors. They also can have a collaborative behaviors with other robot dogs. So these are a few examples of bio-inspiration robots. Okay, so the key characteristics for bio-inspiration, right, is inspired by nature. So which means the robotics functionalities, the structure movement, right, is actually inspired by specific animals, organisms. Okay, And then the purpose, right, is to enhance the mobilities and also the functionalities. So that's a key purpose, either climbing or swimming or even flying, okay? And then, so that's why it's always used in the fields like explorations, like healthcare, disaster response, okay, etc. Okay, so the key is to enable new capabilities and also with efficient movements. Okay, so that's why when you see the application, right, for bio-inspired robot, right, it's always the tough environments. For example, the search and rescue, right, rubber navigation. So these are all rough environments, bomb disposal, right, marine research, or the drug delivery. So these are the typical, the classic application for bio-inspired robots. Okay, so what's the difference between these two? Okay, so for embodied intelligence, right, so the definition is the intelligence will arise through the interaction with the environment. Okay, and then the body design itself contribute to the problem solving. And then the focus is body plus environment. But for the bio-inspired robot, right, the robot is only modeled after biological systems. Okay, and then the key idea is mimicry of the living organism to achieve a functions. And also it's just borrowing the principle from nature. Okay, so one example is soft gripper for embodied intelligence. One example for bio-inspired robot is robot fish, right, swimming. Okay, so the embodied intelligence doesn't necessarily to based on biology. Just now I talked about the delivery board, right, the autonomous vehicle. So it doesn't necessarily to rely on biologies. Okay, so but for bio-inspired robot, right, so it's explicitly inspired by biologies. Okay, so but there are some overlappings because if we leverage, okay, so some of the bio-inspired robot, right, they're actually using the body dynamics to aid control. So that's why it's actually can be considered embodied intelligence. Okay, so that's some overlapping. Okay, so how to design? So how to make your bio-inspired robot embodies? So the first is to start a biological mechanisms, and then you encode into the robot's morphology or materials. And then you use simple bio-inspired controller, for example, the central pattern generator or reflexes. So central pattern generator is something like a spine cord, right? So spine cord is mostly for the rhythmic movements. For example, walking, right, breathing. So these are all controlled by CPG, okay? And then reflexes is for the sudden movements, right, sudden reactions, sudden changes, okay? So then you can validate by whether it's showing lower control or higher robustness. So to validate whether it's embodied, okay? Okay, so just now we talked about so many about embodied intelligence, also bio-inspired robot, right? So what's the link between embodied intelligence to Industrial 5.0? So nowadays we keep talking about Industrial 5.0, right? So what's the connections between these two? Okay, so I think most of you know Industrial 4.0, right? So Industrial 4.0 is first introduced in Hannover Messe in 2011, and then popularized by this person called Klaus Schwab. So he's the founder for Economy Forum. Okay, so this Industrial Revolution, right, is actually joining forces of technology such as AI, gene editing, or advanced robotics. So this technology blurs the boundary between cyber physics systems. Okay, so in this area, right, so in this industrial revolutions, it introduced a lot of tools, right? For example, automation, robotics, IoT, AI. So the focus is efficiency, improve productivity, or cost, or reduce cost. Okay, so in this industrial revolution, right, the tools shape us. So the tool will cause a lot of disruptions. So these are all the disruptions caused by the Industrial 4.0. For example, it displayed many manual or repetitive jobs. A lot of people get retrained, right, during these industrial revolutions. And also, it shifted our human role to more value-added jobs. For example, monitoring, maintenance. Okay, and also it make human to adapt to machines. Okay, so that's a key key focus for Industrial 4.0. Okay, but now we have, so that's where the Industrial 5.0 emerged. So Industrial 5.0 is here to focus on the sustainability, resilience, and human centeredness. So you can see all these keywords, right, are very positive. All these are very positive keywords. Okay, so Industrial 5.0 is not a replacement of Industrial 4.0. It's actually a coexistence. Okay, so Industrial 4.0 actually reshape the tools. Just now we talked about the Industrial 4.0 is a tool shaping us, right? But Industrial 4.0 is actually the tool, we reshaping the tools again, but with a human-centric values. Okay, so the key for industrial 4.0 is actually the tools are here to enhance human abilities. It's not to sideline them. And also the cobots or embodied intelligence is to work alongside with human, not to replace human operators. Okay, so there's a renewed focus on inclusion, well-being, and resilience. Okay, okay. So I'll give you one example. So sometimes we feel very burnt out at work, right? So what we do? So sometimes we feel burnt out at work. So what we do? What we do? Besides resign, what we do? Huh? We take a step back, right? We take a step back. We spend some me times, right? We go for holiday, long holidays, right? We do meditations or focus on mental health. Okay, so the industrial 5.0 is the me time for industrial 4.0. Okay, so it's a rebalancing. So it's not replacement of 4.0. Okay? Okay, so embodied intelligence is a perfect enabling technologies for industrial 4.0. So you can see these are a few examples of embodied intelligence in real life. Okay, so the first one is this cobot, right, collaborative robots doing pick and blades, okay, in the manufacturing, right, in the factories. The second one is this cobot doing assembly, also in the close proximity with the human operators. Okay, so the third one, this cobot doing this swab test, right, during COVID testing. Okay, the last one, robotic barista or bartenders, right, mixing cocktails or making like coconut latte for you, right, in the mall. So these are perfect examples of industrial 4.0. But these all like enabled by embodied intelligence. Because embodied intelligence allow the robot to adapt to the dynamic environments, and also ensure it's a natural, also safe beside human operators. Okay, so embodied intelligence is the key, to unlock industrial 5.0. Okay, so how about Singapore? Okay, so in Singapore, right, by 2030, around 23.8% will be aging population, age 65 and above. Okay, by 2050, this rate gonna increase to 33%, which means 1 in 3 Singaporeans will be age 65 and above. So which means 2 young Singaporeans have to take care of 1 elder Singaporeans. So it will cause a lot of burden to our CPF system. Okay, so also it will cause a lot of labor shortage, right? So that's where the robot actually can come to help, right? Robot can work 24/7, right? Robot can also no complaint, right? At least for now, no emotion, right? Robot also don't strike, right? Also don't have unions. They don't take MC without MC, right? Some of you take MC without MC, right? Okay. So robot is perfect to solve the labor shortage issues. Okay, also for Singapore, right? The Singapore GDP per capita increased from 1960 until now, even though we have some small dips during the Asian financial crisis, 1998 or 2008, the global financial crisis, or even SARS and COVID. There's a small dip, but the overall trend is still upwards, right? So which means we have more money to spend. Okay, so if we have more money to spend, what we do? We're craving for more personalized or better education, leisures, or healthcare system, right? So AI is perfect to achieve. AI also have the potential, to uplift every dimensions of our human lives. Okay. Okay. So besides all this, right, AI also have proven records, right? Based on one McKinsey study back in 2022. Okay. So around 40% to 50% of the company have report a cost decrease after adoption of AI. And also around 60% of the company, they actually report revenue increase. So after they use AI. Okay? So they have a proven records, right? So it actually can benefit the manufacturer, benefit our society. Okay? Also AI is getting smarter and smarter, right? So you all saw this kind of benchmark, right? The ChatGPT against all the prevailing tests like GRE, SAT, the lawyers bar examination, right? So they can achieve around 90 percentile. So it's very scary. So they are better than 90% of the students taking part into these kind of examinations. Okay. Also, have you all heard this humanities last exams? Never, right? So this is the most difficult questions organized by all the field experts, right? From professors, doctors, engineers. Okay. So that's why it's called the last exam. So if the AI can achieve 100% for this exam, right? So which means the AI has the same capability as human. That's why it's called the last exam, right? So now the Grok 4 developed by XAI, so they can achieve a 23.9% for this exam. Then the second is Gemini, right? Gemini 2.5. can achieve a 21.1%. So even though the rate is not very high, right, but it already means something. Okay, it already means they actually, so for us human, we cannot even achieve this kind of score. Okay, so AI is getting smarter and smarter. Okay, so which means AI and robots are inevitable, right? Just like Thanos, right? He can snap his finger and wipe out half the populations, right? So it's inevitable. Okay, so if AI and if inevitable, so how about Singapore? So Singapore is one of the few countries start to, doing the AI regulations, right? So back in 2017, we have AI Singapore, 2019 National AI Strategy 1.0, and 2023 National AI Strategy 2.0. So Singapore is the first few countries study after US, China, and Korea, okay, to launch the national AI strategies. So which means the law and regulation and frameworks are there in Singapore, okay? Okay, also, you all heard the news, right? Singapore government pumped a lot of money, right? $1 billion to boost the infrastructures of AI, grow talents, and foster public-private partnerships. And also, the AI initiative, right, will be included in the RE 2030. Okay. Also, another $150 million boost to encourage the enterprise to partner with cloud providers for computing powers. Okay. So the overall Singapore, also recently, right, Lawrence Wong, the PM of Singapore, so he actually also mentioned about robotics and AI in his National Day speech, right? Also, he mentioned about continuous learning. Okay, so the overall Singapore government stance in AI adoption is very positive compared to other countries. Okay, so how about ecosystem? So for the robotic ecosystem, right, Singapore has a complete robotic ecosystem. Okay, so from public sector, we have national smart nations, national research foundations. So these are the government bodies. So they set the directions. Also, they give out the fundings for robotics and AI research. And also in the academia, right, we have NUS, NTU. So these are the universities who they conduct the fundamental research. Also collaboration with private sector, right, to make the breakthroughs for robotics. Okay. Then for industry and startup, right, so we have SD Engineer, Hope Technic, these kind of companies. So these are companies are bring the ideas into products. Okay, so they are doing the commercializations. Okay, so then all these, right, we have a national robotics programs. So these are the horizontal platforms to link up different sectors, public, private, academias. Okay, so Singapore has a very complete ecosystem of robotics. Okay, then how about the robot densities? So according to the International Federation of Robotics, right, so Singapore ranked number 2 in terms of robot densities. So Singapore have 730 robots per 10,000 employees. So just after Korea, South Korea, okay? So Singapore, the robot density is 5 times of the world average, which is 151. Okay, so it's also much higher than Germany, Japan, this kind of very established with manufacturing traditions countries. Okay, so which means reflect the country's strategy to offset the limited labors. Just now I talked about aging population, right? So offset the limited labor forces with a high adoption of robotics, AI, also advanced manufacturing. Okay, but how about the AI adoptions? So the AI adoption actually is very slow in Singapore. So the SME drive 99% of the Singapore business, employ 70% of the workforce. But the SME only adopt 4.2. Only 4.2 of the SMEs adopt AI. So slightly increased from 3.5 in 2018. But for the MNCs, it's slightly better. 44% of the companies adopt AI, so increased from 60.7 in 2018, according to MD reports. Okay, so if we consolidate all the information, right, which means even though we have so much robots, right, but these robots are very concentrated inside the MNCs, okay? And also, so you can see here, right, the AI adoption is very, not much, right? So which means some of the robots are actually using hard automations. So there's not much AI elements combined with the robots. So that's a hard reality for Singapore, okay? So what shall we do? What shall we do to react? Okay, so call for actions for everybody. Okay, so first, what should our company do, local company do? Okay, so I summarize purpose. So what's purpose? So P stands for prioritize. So prioritize the ethical and trustworthy AI usage because AI will be an integral part of a society. So we must first make sure the AI is ethical. But secondly, we need to upskill the workforce, right? We need to educate the public that AI is not here to take your jobs. So AI is here to enhance your capabilities. Okay, so for R stands for reimagines, right? Reimagine the collaboration with agentic AI, embodied intelligence. So AI in the future, right, will just become our colleagues. So we are working alongside with AI, okay? But we also cannot just adopt AI for the sake of adoptions. Okay, we need to analyze return on investment. Also, we need to analyze whether there's a need to adopt AI. If there's a need, right, then we can go ahead to start to plan. Okay. So P stands for pilot with small projects. So don't just straight away go full scale. Okay, so try to do a pilot project either with universities or with a research institute, right, to see whether the robotic solution or AI solution makes sense. If it makes sense, right, then we can scale up. Okay, so O stands for orchestrate, right? So because Singapore governments have so many fundings, right? For example, the productivity solution grants, the enterprise development grants, energy efficient grants, have so many grants for the company to apply. Okay? So as for stimulate, right? Because we need to make sure our infrastructures, the legacy infrastructures can be compatible, right, with the future AI solutions or robotic solutions. So lastly, E stands for embrace. So we need to embrace now, right, the human centrics, which is the future, which is also the key for Industrial 5.0. Okay? So how about individual? So what shall we do? Okay, so individual, I will still quote the very famous quote. I think Jason Huang from NVIDIA, he also mentioned a lot of times, right? So AI is not here to take your jobs. Someone using AI will take your jobs. Okay, so someone using AI will replace you. Okay, so what should individual takes? What actions should individual takes? So I summarize T and C. Not term and condition. I know most of you don't read term and condition, right? Okay, so T stands for tools. So we need to get familiarized ourselves with different AI tools, right? So first we need to find our niche areas. So whether you want to do machine learning, whether you want to do data visualization, or whether you want to do cloud platforms. So find your niche areas and dive deeper to find all the available tools for you to utilize. Okay. So C stands for continuous learning because AI is evolved so fast. Even for us, lecturer, right? So we need to revamp our courses every run. My colleague, even every 2 weeks, he need to change the course materials. Why? Because he's teaching the large language models. You know, every 2 weeks, some company announce a new model release, right? Okay, so you have to revamp the course constantly. So same as you, right? So you also need to continuous learning, continue to upskill yourself to make sure you have the state-of-the-art knowledge of robotics and AI solutions. Okay? So if you are interested in robot, right, you can actually consider some of the robotic tools, right? For example, the Copenhagen module code, Unity, right? So these are some of the tools you can use for deep reinforcement learning in a virtual environment. Okay, so NVIDIA-ISS is to validate your physical AI, and this visual component is for digital twins, right? So this is just for your reference. I think most of you are already using the AI tools, right? Either for linguistics or musical or even scientific discovery, right? So these are all available tools for you to use. Most of it are free as well. So they provide a free tiers. Okay? So you are interested in machine learning, right? You can consider these kind of frameworks like Keras, TensorFlow, or Scikit-learn, right? So these are AI frameworks and libraries for you to use. Okay? Then how about Gen AI, right? So many, right? ChatGPT, Grok, Cloud, DeepSeek, Midjourney, etc. Okay? So you must know which model, large language model is best for which kind of applications. For example, some models are good at reasoning. So some models are good at generating pictures. For example, ChatGPT 4.0. Some are very good at reasoning or codings. For example, Vercel are good at coding, right? Coding apps. Okay, so you need to know which tool to use for different type of applications. Okay, but also be aware of the cognitive depth. So according to MIT study recently, right? So even though ChatGPT can increase our efficiency by 60%, but you also reduce our connectivity, brain connectivities, okay, by 32%. And also 83% of the ChatGPT user, they cannot remember a single sentence they wrote. Okay, so the article generated by ChatGPT, right, is also soulless, lack of ownerships. Okay, so we must be aware if we over-reliant on these kind of Gen AI tools, right? Okay, so it will lead to a long-term underperformance across brain behavior and language measures. Okay, so in summary, we need to use AI tools consciously. Not anything just prompt, anything just throw inside ChatGPT, generate, right? So we must use consciously. So we cannot lose our capabilities to think, innovation, and intuition because that's differentiate from human to animals, right? Okay, so you are interested in continuous learning, right? You can consider our programs. For NUS-ISS, right, we not only provide the master programs, right, in AI, in data science, in software, we also provide short courses, right, in different fields, right. We have practice experts from different fields, okay? Okay, so this is actually where I'm coming from, right? So I'm under the AI practice. So we have a master of technology in the AI systems. Okay, so we provide this type of courses, right? So you need to do two foundation, like graduate certifications, plus 2 specialist graduate certifications, all these 5. So you can choose 2 out of these 5. So 4 GC, you can actually accumulate to a master degree, okay? And if those type of routes are not suitable for you, right, you can also consider this kind of stackable routes, which means all time, all targets. So you have up to 7 years to finish the 4 GC plus the capstone projects. Okay, so this one you have longer runways. Okay? Okay, so I think that's all for me. So you all can scan this QR code to provide the feedbacks. Also, you can find my colleagues, Jason, sitting behind to collect the session cards. Right.
Anyone?
Emotion and behavior AI. So that's a way to one layer to understand humans from robots. So maybe discussion, maybe projects or wait. No, I represent the emotion. Emotion is used for behavior and
Anyone collecting the session card?
yes.